Hey everyone. In this video, I'm going to be showing you how to use the Desmos construction tool. So it's Desmos. There's a link to it, but it's desmos.com/geometry. There's also another tool which has support videos on GeoGebra. They're similar, but I wanted to make sure that you are seeing both. So in order to do this, I'm going to walk you through, I believe, 3 different types of constructions. And I think a great thing for you all to do is to either have this opened on your own screen as well and listen while you work, or even just to write notes to yourself so that you can go back and reference it. So the first one that I'm going to be showing you is perpendicular bisector. Perpendicular, oh, there's like major delay. Bisector. So the symbols, let's talk about that for a moment. Perpendicular is this symbol, right? Perpendicular means 90 degrees. So it's 2 lines that intersect, or 2 segments that intersect at 90 degrees. And bisect means that they cut in half. Cut in half, right? So it means 2 different things. This is the symbol for perpendicular. So to start this, I'm going to start with a segment. Okay, so I'm going to stick a segment, and you're going to want to give yourself enough room here. I'm going to give a segment right here. And I want to create another line or a segment that is the perpendicular bisector of this one right here. Okay, so that means that it's going to intersect this at a 90-degree angle, and it's going to cut it in half. Well, if it's cutting it in half, it's going to intersect this segment at what we call the midpoint. So I'm going to start off, and you don't need to do this, but I'm going to do it anyways. I'm going to indicate the midpoint. So I'm just going to stick a point there. So this is the midpoint. That's halfway. So my second line is going to go through this point, and it's going to form 90-degree angles. So the first thing that I want to do is I want to create an arc that goes past this halfway point. So in order to get that, I'm going to go over here. I'm going to make another segment, and that other segment has to be opened wider. So I need a circle that has a radius that's larger than from here to here, from the end point to the midpoint. So I'm just going to create a second segment that is longer than half of the original segment. Doesn't matter how much longer, just longer than halfway. So I'll go with that. I'm going to grab my compass, and this is going to force my compass to open with a radius of this segment. Whoop, right? So I've got a circle. That's my compass. Right? A compass would form a circle that has a radius of that segment. If I go over here, okay, good, right? So I can see it was open to more than halfway, and I'm going to click. I'm not going to change my compass, so I'm actually going to go back over here and get the same compass, go to my other end point, and put another point. As long as this segment is longer than halfway, this will work. So my segments my arcs or my circles could have been bigger. They couldn't have really been too much smaller. So what I'm now going to do is I'm going to go ahead and draw a line that intersects right here and right here. So right here and right here. And check this out. That line, oops, I have to write with the correct side of the pencil. This line, this one right here, is the perpendicular bisector of the segment I started with. This is a 90-degree angle, and it went right through the midpoint. This is a perpendicular bisector of what we can call AB. Okay, so that is how we construct a perpendicular bisector. And then if you picked any point on this perpendicular bisector, it's going to be equidistant from my 2 endpoints, right? Just like the midpoint was. The midpoint might be the closest distance, but any of these points along the perpendicular bisector are going to be equidistant. Amazing. Okay. We're going to do another one. Sorry, I gotta figure out how to erase though. Ooh. Ooh, I don't want the grid. Projector mode is cool. How do I erase everything? Oh, look, I can even see some information over here. So I'll do a new construction. And I have to erase all of this fun stuff. The next one we're going to do is called an angle bisector. So an angle bisector, you might be able to think a little bit about this. So we're going to start with a what? Ooh, an angle. And bisect means what? Cut in half. Right? So if I start with a 70-degree angle, I'm going to be creating two 30-degree angles. They're going to be adjacent, right? They're going to share a ray. So I'm basically finding the ray that cuts this angle in half. So I need to start with an angle. I'm going to change to this. I could use the segment tool. I could use the ray tool, whatever floats your boat. So here's going to be my angle. And remember, I don't care how long this is. Like, it keeps going. Think about this, that like it keeps going over here. Think about these as arrows. Don't like feel like these points are meaningful to us right now. What I'm going to start by doing, and maybe you remember that this point is called the vertex. What I'm going to start by doing, I keep forgetting to switch back, is I'm going to go ahead and grab this circle tool. This is going to be the center of my circle, and I'm going to create a circle. I don't care about that other point, so it's not super impactful. So just create some sort of circle. These 2 points are going to be very helpful to us. Right, so I just created a circle that had a center at the vertex of my angle, and where the circle intersects the sides of the angle, the rays, I'm going to put points. I'm also going to, and this isn't completely necessary, but I'm going to do this. I'm going to create a segment that goes through these 2 points. And I want you to think about right now, what we just did earlier in this video is you're going to be doing the perpendicular bisector of this segment. That's ultimately what you're going to be doing. And that perpendicular bisector is actually going to go right through this vertex. So I'm going to go ahead now and I'm going to create another. I want a segment that's longer than halfway, remember. So I'm going to create another segment over here just for, this is like my work segment. Seems like a good thing to call it. And bam, there's my compass. I go over here and bam. Let's re-get that compass. Bam, there's my compass. Whoop. So a little confusing. There's a lot going on right here, but I have a point here and a point here. I'm going to go ahead and draw a line that goes through those 2 points and watch how amazing this is. Oh my goodness. It went through the vertex too. And this is going to be mind-blowing, guys. Let's find the midpoint of this. Oh my gosh, it went through the midpoint also. Right? So, I feel like I need a good color here. Here was the angle I started with. Right? So, angle I started with. And here was the bisector that we just created. So if you can see, it cut it right in half. So that first circle I created that had a center at the vertex, it didn't matter, right? So it didn't matter how big or small that circle was. I just needed a circle. I located those points, and then I basically just did the perpendicular bisector of those 2 points, because what happens is that any point on that bisector is equidistant from these 2 endpoints. right? So from these 2 points right here. So if I picked any point on this and I dropped a perpendicular, and I dropped a perpendicular, that distance is the same. So any point on the perpendicular, on the angle bisector is equidistant, perpendicularly equidistant, I guess is a better way to say it, to the two sides of that angle. And that would be true of any point here. Any point you pick on that perpendicular bisector. If this angle was originally 70, this is now 35 and 35. If you do this and there are no points of intersection, you made a mistake somewhere, right? So these two are adjacent angles that are congruent. All right, so we've done perpendicular bisector, angle bisector, and I want to do parallel lines. So I would say if practice these two, these are really the key ones. And then if you're feeling confident and you're up for the challenge, go ahead and keep watching. And I am going to go ahead and do one more on this video. So parallel lines, two lines that never intersect. Right, so and parallel lines are going to be something we'll learn more about. So we might come back to this construction as a class when we get to literally an entire topic about parallel lines. So the symbol for parallel, so if I want parallel lines, let's say I've got line AB is parallel, it's just the double L's to CD, let's say. And they never intersect is really what's happening there. So I'm going to go ahead and I'm going to start with a line on my paper. Or on my, whatever you want to call this. And I'm going to start with, I'm going to put a point somewhere not on the line. So let's say like right here. You know what? I want that a little bit down. Doesn't matter. It could be anywhere. So what I'm going to do is I'm actually going to create another line. And this is where it's like pretty opened here. My line can go anywhere through, I'll call this AB. It can go anywhere through AB, but it's got to go through this point. All right, we're going to switch. So boom, and then just create it. Doesn't matter. I'll stick it right here. Right, it could have gone the other way. This is just what I chose to do. So if you can see, there's an angle that's formed right here. I want this same angle to just be shifted, we'll call it translated, maybe you know that word, up to here. But I can't just estimate it, right? If I can translate it up, that exact angle, that new line that goes through that point is going to be parallel to AB. So I need to, what we're going to refer to as copy this angle. So I'm going to go ahead and I'm going to take a circle. And I want the center of my circle to be at this point right here, wherever my point of intersection was. It could have been A, it could have been B, it could have been some other point on here. And I'm going to create a circle. I don't want my circle to go past that other point. And you know what? For ease of doing this, I'm going to call this G. And I'm going to call this G prime to indicate that it's like the new G. So if you can see, the radius of my circle goes from here to here. I'm going to make a segment that is that so that I can grab my compass and make my compass that same side, right? So, oh, look, same circle. Let's shift it up. Ooh, bam. Right? So I'm just moving it up. So now both of my circles, G and G prime, have the same circle around it, both of my points. Okay. So now I want to know, I'm going to go ahead and I'm actually going to create a segment from this point of intersection to this point of intersection. You know what? I can even call that, I'll name those. Let's call it S and R. I'm just making up letters. Do you see how S, well, this was G and this was S. This is G prime, and oh, check this out. There's S prime. So I now want a circle, or I can use my compass tool, that is opened from G to S. Oh, no, I don't. I'm sorry. Ignore me. Back. I want to figure out this segment is what I want to do. So I'm going to take my compass tool and I'm going to open my compass to be the length of S to R. And then I'm going to go, woo. No, why didn't that work? I'm sorry, having issues now. Back up. I want my compass to go, there we go. Right, so I made that segment and then I'm going to slide it up to S. Hopefully you see this point of intersection. Well, that's our new R. That's R prime. So if I connect G prime to R prime, just like G to R, I've got it. Let's grab this and go woo, woo. And check that out, I just constructed parallel lines. This one is a little bit more tricky. And if you saw, I just had some trouble with it. So this is how we can indicate. We can put these arrows to indicate what's parallel. I did not need to. I just felt like I wanted to indicate that those would be parallel. So I copied this angle, SGR, up to here, S prime, G prime, R prime. I'm not ever just putting a point. My points are coming from points of intersection of these circles, or what we often refer to as arcs. So these were 3 constructions, and this is really the order that you should be mastering them in. So perpendicular bisectors, definitely the most important one to us. Then I would say angle bisector, and finally parallel lines. So if you need to go back and rewatch any part of this video, feel free to. There's also videos helping with GeoGebra if that tool comes a little bit more naturally to you. Thanks, everyone.